without any sub.
Yo, hello.
All right,
Welcome to
so
my
you can
channel,
see that
guys. Today I got
the
this is
agenda for this
some
specific lecture is really straightforward. We're going to talk about Elastic Kubernetes Service (EKS). All right, and feel free to look into other services like the ECS, the EC2, right, and the ERM. Right? All of them will have a different purpose when it's come to, cloud services. All right. And once again, I actually backing you to actually do the survey, right? At the end of the day, the survey is a very beneficial way for you to raise your voice, right? I want to hear about your opinions, your feedback, right? What is the good thing that you like? What is the thing that can be improved upon for the upcoming semester, right? So please try your best to spend like 2 or 3 minutes to do it for me, all right? It's very important for me, okay? For us to build a relationship, right? Because at the end of the day, you might meet me again in the next future semester. All right, cool. So let's talk about the deployment technology transitions, right? So in the past, every single application will be monolithic. Let me change the icons. Yep, monolithic, right? Application is mean that we have one server, right? We host every single applications on one single server, right? Technically, that's it. And because that server hosts many applications, right? Technically, it means that server will be very big, right? It's a huge server contain all the applications. And the thing is that could be very risky because if one of the applications, right? If one of the application got crashed for some reason, for some error, right? Or for some mistake, then potentially it could affecting the whole server as a whole, and that could deny all the service for the client, right? That's really bad. Imagine if RMIT hosts all the application or services on one single server, and let's say something happening on the website of RMIT, and it's crashing the whole server. It means that now, if you try to submit your assignment on Canvas, you can, right? If you try to pay tuition, like money for the school, you can't, right? Because all of them are hosted on the same server, right? That's very risky for a business to host all the application on one single big server. So that's why they have to move to a more robust implementations, which is the microservices, right? Microservices mean that very simple. Like you host it on multiple different server, and each server only have one single job. That's it. So if this one crash, right, the other services are still available for the client to use. So that is nice. But at the end of the day, if this one crash, then we need to figure out a way to, okay, no, not yet. So this one is all right, it's good. But at the end of the day, there's two problems. The first problem is, if you want to migrate this server to a new server, right? Technically, you need to install everything from scratch again. Imagine this one is using Java and Maven and stuff, right? You have to install Java again, Maven again, and at the end of the day, it's quite challenging. Technically, there must be a developer who already deploy this server manually. He have to run a manual guy, right? So for the later on when he quit the company, there's a new developer come in, and if he need to migrate that server to a different server, he got to follow the guy, like, okay, first you need to install Java, then you install Maven, and then you run this command, right? So exactly what we do in the lab 2 and 3, right? So it's very manual, right? Step by step. And also, there's a risk that if the server is down, right, then we want to relaunch them again. We want to back up again a server. There is no easy way, right? At the end of the day, we have to figure out a way that we can easily deploy without worry about dependencies. And also, we want to make sure that, there's something wrong with my pen. I can't go down here. Anyways, so we want to make sure that if the recruiter, right, website is down, we want to create a bunch of them to share the load balancer, right? So one way for you to solve being the dependency is actually using the container, like Docker. Technically, Docker will allow you to host the application and all the dependency, the libraries, the framework inside one single container. And as a DevOps engineer, you don't need to worry about the details of limitations of how to deploy that specific application, you need to launch the container, and that's it. If the container can launch, you can access that. Right? So technically, with that Docker, and then what if we have tons of different server, right? And that could be very complex. Then you try to using Kubernetes, because now you can create some rules that okay, I want these two to have at least 2 or 3 different server as a backup, right? And if one of these survive the container down, then I want to relaunch that container again, and all of them can be done easily using Kubernetes on the cloud, right? So that's the beauty of it. We have transitions from a very big server with many applications on it to many server with only one application on it, and to Docker would allow you to don't worry about anything when it comes to dependency and the framework, right? And just launch that container. So everything here are container, right? And we don't need to worry about how to install the setup, right? Set up the framework library for that specific application, right? Everything can be done by container. And then maybe we want to scale them up and scale them down, right? Also based on the demand, and also make sure that they are happily collaborate inside one single cluster. So that's why we are using Kubernetes, right? So yeah. Right, so and I just want to let you know that even though Kubernetes are created by Google technically, and then so Google, they have the GCP as a cloud service, right? But the thing is, AWS technically totally dominate the Kubernetes, right? So 63% of all the Kubernetes workload are run on AWS today. Okay, so it means that we are making the right choice to actually learn Kubernetes on AWS. Okay, and let's look at the Kubernetes environment here, right? So so you can see that throughout the years there are some transitions between different Kubernetes environment, but the most interesting things for you is actually this one, right? So you can see that majorities of them are still run in the mini cube environment, which is like a toy environment for learning. Technically, it's showing you that hey, a bunch of them still deploy in a very playground environment. Okay, but definitely these are more serious, right? So these are more serious. So some bunch of them are actually install Kubernetes on the premise, right? So on their own virtual private server. And then that is the transitions going up here. Does it mean more and more people are trying to install Kubernetes on the servers, right? And then we are gonna learning this one, right? So we are using the cloud provider managed Kubernetes for us with AWS, right? And you can also see there's the transitions going up here. Okay. All right. Okay, so let's remind about how Kubernetes work again. So at the end of the day, you have 2 parts, right? So what the first part is the control plane. The control plane is like the brain of the cluster, right? So it's got the API server, allow you to communicate with that and allow it to communicate with the worker node. And you have a scheduler, the controller manager allow the control plane to figure out, okay, what is the resources need to be launching on which specific different nodes, right? And then we have this one, which is like a storage to contain important information of the cluster. And you have a bunch of worker nodes here. Node can have multiple different parts, right? And then it could run on the Docker's container, right? App technology. It have the kubelet. Kubelet is like, you could say that every single worker node need to have a kubelet, which allow the kubelet to control whatever happening inside the node, right? And then we have a kube proxy, which is like control the network inside the worker node. So, and you don't dealing with the worker node directly. You are using the kube control, right? So also some application you can using user interface, like beautiful dashboard to communicate with the control plane. But we are DevOps engineers, so we are using command line. So we are using kube control to communicate with the control plane to let the control plane control whatever inside the cluster. All right. So there's two parts only. Okay. And this part are very difficult to set up. Very difficult. And also this part also very difficult to set up. Right. So many stuff to set up to actually learn Kubernetes, even like to run as learning and as production. Right. So that's why I can tell you that sub Kubernetes are very hard. So that's why Kubernetes is one of the challenging topic to learn in DevOps, because it's just too complex to even set up, right? So definitely the reason why it's so hard to set up, because it's a complex infrastructure, and you can see that so many small details coming inside the control plane, and then how the control plane control the worker node in the cluster, and then each of the node need to have the specific component of the kubelet and then kubeproxy and all the pod and Docker and stuff, right? So if you really want to set up, like if you really want to know about Kubernetes inside out, you can just follow this tutorial step by step, right? This is Kubernetes the hard way. Technically, you are very hardcore. You want to set up everything from scratch, okay? Like no script, like technically no script. Let's go hardcore, but we don't want that. Actually, not in the scope of this course, anyways. So that's why we're gonna go for the easy way, which is we're gonna use the Elastic Kubernetes Service (EKS). That means that Amazon Web Services is gonna control the control plane for it. Like we don't worry about the control plane or the cluster; they take care of that for us. Okay. So the EKS stands for the Elastic Kubernetes Service. It is a service allow you to run Kubernetes on AWS. That's it. Very straightforward. EKS. All right. So how EKS actually working is very simple. So EKS is a service, right? Managed service that allow you to easily run the Kubernetes on AWS without need to install or operate your own Kubernetes control plane or worker node, right? So you don't deal with any of the installations or the setup for the control plane or the worker node, right? Technically, you don't need to like write any script to install step by step, right? So the EKS is actually provide you the control plane already, and it also give you the cluster already, and your job is actually to figure out so technically, and you can determine how many nodes you want inside your cluster, and then it's gonna deploy some worker for you already. So your job is actually very simple. You connect to the EKS, and then you're using the kube-control to control the cluster, and yeah, that's it. You run your applications. Straightforward, right? And for the official documents for EKS, please check out the official documents from AWS, right? So I think it will be interesting for you to go through that, because they're going to have different sections for you to learn about EKS, get started, cluster, node, storage, network. There's a lot of them. Definitely for this course, we're going to touch base about the very basic of the EKS only. All right, so EKS, so what is the feature and the ability of EKS? So EKS run and scale Kubernetes control plane across multiple available zones, right? So make sure that it's never down, right? Because control plane are very important to the cluster.
So let's
and then there are many applications that you can integrate with the EKS for the scalability and for security, right? For example, you can using the ECR for the container images, right? Sometimes you don't want to using the Docker Hub because it's not free, and also it's actually on the Docker server.
In this
right?
video, I can
if
show
you want to
how
post
to
it,
use this distributor for
right in
Jenkins.
the AWS, you can use the ECR for that. The Elastic Container Registry, and then also the EKS allow you to using the Elastic Load Balancer to distribute the load of the request from the client to your application. So it's going to spread out nicely in the cluster, right? And then we have the IAM for the authentications, right? And then we have the Amazon Virtual Private Cloud for isolation. It means that not many people can access to that based on what you want, right? So it's increase the security for the cluster. Okay, I'm gonna explain quickly about this. Technically, you here, so you are on your local machines, right? Or you on another EC2, right? So in our lab, we're gonna create another EC2, right? With the Q control, right? We're gonna connect to the ECAS. We're gonna say, hey, I want you to create a cluster for me with 2 nodes, right? And then the ECAS gonna create a bunch of worker node, and these worker node gonna be have auto scaling as well, right? Because if while the node is down, it's gonna automatically launching up the node again, and you get a bunch of nodes. And if you expose those nodes into the service of Kubernetes, right, it automatically create a load balancer for you, right? So now the client can access to this application through a load balancer. So if you have 100 different worker nodes here, they're gonna spread out, right? The request gonna spread out nicely among that 100 different nodes, and that's the beauty of it, right? So yeah, so that's it. So that's really straightforward how ECAS actually working.
So let's select this one,
and
we have to continue with.
So how do you start with the ECAS on AWS?
Option,
super
right?
straightforward.
So
There's a few steps. You can create the ECAS cluster on the Amazon console. In our case, in our lab, we don't create the
network
ECAS
details,
cluster through the console. We create them on using the EKS control. So we are using this command line interface to actually create the cluster for us. And then after you create the cluster, you can actually launching some of the EC2 nodes in that cluster, right? So in the lab, we're gonna launching 2 of the EC2 nodes. So when your cluster ready, you can configure your Kubernetes tools like the Q control here to communicate with your cluster, to manage your cluster. And then, yeah, so technically after that, you can using Q control to deploy some application through using images, right? And then you can just like check them out. So these are very simple, like step by step, very simple. And ideally, if you want to sub for the EKS, sorry, this is EKS, not AKS, EKS, you need to have 3 command line interface packages. The first one is the Q control. So you know about Q control already. So Q control is allow you to communicate with the Kubernetes API server inside your cluster, sorry, it's inside your control plane, right? Technically, Q control allows you to communicate and control and deploy application on the Kubernetes cluster, straightforward. And then we have another command line interface, which is the EKS control. So EKS control is super simple, right? So we are using 1 or 2 commands in our lab to create and destroy the Kubernetes cluster on the AWS. That's it. So this one is like very convenient special command to just create a cluster and destroy a cluster, and maybe checking the information of the cluster. All right, and then in case you want to using using other services of AWS, right? You like the RDS or the ECS, right? Then you might need to install the AWS command line interface. Because with this, you can communicate and you can like manage other services in AWS, including the EKS, including the ECS, including the ECR command line.
So I'm navigating to my private key file. My key private file is located
gonna create
the document folder.
Right, and then you can see that the cluster is actually deployed on your EC2
necessary to ensure my key is not publicly viewable. So I can
so this is lab for this week.
Execute this command.
And technically, it's aware that this is the learner lab, right? So it's not like a normal account on AWS. There's a lot of restriction you need to follow. But technically, for using EKS, you need to using the AIM lab role. But this one is not good enough to launching the cluster using the EKS control. And at the end of the day, you need to add another role. So this is, you can see that. So this role got the EKS cluster and worker node policy, which is good. But at the end of the day, you need to create another policy, right? Permission policy to create role.
Before
like
we go
this.
with Jenkins and installation on our Ubuntu server,
So
we have
you
to
can see
make
that there's a create role right here.
we have created our
Yep, right here. So that allows you to using the EKS control
we place
to create a
3
cluster.
files there. The first
So,
one is called Moodle_.
If you want to, you can stick to the dashboard, right? Up to you. But we are the DevOps engineer, so we try to using the command line interface as much as possible.
Okay.
So
you
gonna create EC2, a special EC2 server.
As you can see,
This server gonna
this
have
has
3
options,
command line interface that I mentioned about.
Arguments,
This special server gonna have the queue control,
we don't have
the EKS control, and the AWS control, right? So AWS command line interface, and then you can install. You can just like normal server. You can install these 3 packages on it.
Okay,
right,
so
and then the moment when you're ready, the moment you choose, you're gonna create the cluster using the EKS control, right?
Yeah, the order of
and you're gonna name cluster here. This is the name of the cluster, and then this is the regions you want to launch. The thing is, we are using Learner Lab, so we don't have much option when it comes to regions. So the region available for us would be the US East 1. So I'm actually launching the T2 small. Okay, I'm a few adventurers. I'm gonna launching that's a bigger like that 3 tier, right?
Okay, so we're ready
and then
to go.
I'm actually set the min node and max node to be 2. Technically this,
just to be able
right?
to,
So minimum 2 node, maximum 2 node. Right? Keep it simple. And then these are the zones that I want to launch inside my regions. Okay. And then after you run that, you can see that your cluster is running. And then you can check the cloud formation to see what's going on inside. And after 20 minutes, so take a long time to finish. After 20 minutes, it's finished, right? And then your cluster is the thing you do last week. Technically, you can launching a different pod, you can launching different services, you can launching different deployments. And then, and this website is available in the load balancer for you to check it out, right? And that's the nice thing about that. And after you finish all the thing, you're gonna play around with the manifest file as well, to quickly create service for you. And then eventually, you finish everything and you want to wrap up. So you try to lead the service, the pod, and then the whole cluster. The cluster costs you money, a lot of money. So you want to finish up by delete the cluster always after you finish the lab.
We click in yes and press enter.
So that's it. So that is the end of the lab file. Right. So wow, it's amazing, guys. We have actually finished all the lab together. That's amazing. Okay. So that is the week for this lab. So that's the lab for this week. So very straightforward. You're gonna sub the cluster. You're gonna sub some nodes in the cluster, and then you're gonna using the queue control to go inside. Experiment with a bunch of pods, a bunch of service, a bunch of deployment, and then check out the website on the load balancer, right? And then when you're happy, you want to finish the lab. You want to delete all the services and the pod inside your cluster, and then finally you want to delete your cluster. Okay, all right, nice. So that's it for the EKS. Okay, I want to keep it sweet and simple. All right, I don't want to overwhelm anyone with EKS.
So
because EKS could be very complex. Okay.
Installation. Let's continue with the installation Google Drive.
Now,
Chrome.
Let's talk about revision
First of
and
all, we have
fast
to
recap.
All information about
I think this is more interesting than the EKS, right? Because some of you guys might not even use EKS in your assignment 3, but this one is more important because I think some of the important information here you might be able to use it later on when you apply for jobs.
It's called wget. So actually we just to be able.
All right. So once again, congratulations for wrap up 12 weeks of this course, right? Awesome.
Distributive. Okay.
Once again, remember to do the ECS, please. Very important. And then, so look at the survey here in 2020. You see that the most popular tool to manage your CI.
We get in this information.
The most popular tool to manage your CI/CD would be the Jenkins.
So it's
perfect. we wrap it up, right? There are other options as well. So I want to keep your mind very open about other options, right? Because we already learned the most popular tool to manage the CI/CD pipeline. You can see that Jenkins is very important because it can do a lot of stuff with the plugins, right? And it's the main pipeline. It's technically the most important piece of our pipeline of the CI/CD, right? But let's look at the syllabus again.
Next one,
so
we have to execute
right?
sudo.
So in week 1, we went through the course overview. We introduced you to the idea about CI, what is CI, what is CD, and what is actually the problem that SecOps is trying to solve here, right? Because without CI/CD, what is the problem, right? And then we realized that CI/CD actually solve a very specific problem in engineering and software engineering, right? And then we'll talk about the tools and the environment, and then we set up some VirtualBox in our lab, right? Alright, for week 2, we talk about the Linux and the command line interface, right? So straightforward. We went through a bunch of bash script and Linux stuff, Linux script, right? So ls, cp,
and now it's the actual execution, actual
week
installation.
3,
So
we talk about Git, Java, Maven, and Tomcat, right? These are technically development tool, right? So you need to have some basic of this development tool of like
learning
throughout the course, because we're using them as a foundations here, right? So Java is for the programming languages, Maven for the bootleg tool, and Tomcat is for the server, right? And then
Linux.
Okay. I think we make mistake here.
Already installed.
Let me check.
Okay, so just run
Let me check.
dash Chrome, then space hyphen version and press enter. Okay. So we have to
Week 3 we learn about cloud computing AWS. So this is not correct.
And then
so week 3 we learn about AWS.
Okay, so
specifically EC2.
Copy and paste it there.
Right, and then so then week 4 we learn about Java, Maven, and Tomcat. Week 5 we learn about Jenkins for CI/CD. Right, and then we realize that Jenkins is very important. With Jenkins alone, you can build a very basic CI/CD pipeline already, right? And then we learn about Docker's container. Week 7, we actually have the personal development week. We have the guest lectures and commit tool to the VNG.
Okay, done.
And then we have the Ansible.
Again,
I will learn about Ansible. It is configuration management tool, allow us to manage multiple different servers, right? If you've got a bunch of servers and you want to like write some playbooks to manage and control all of them and group them into different group of like servers. And then week 9 we're gonna learn about orchestrations, right? You know about container orchestrations. Specifically we'll learn about Docker Compose. Right.
Okay, we got it. The next step we have to install unzip.
Compose allow you to write a bunch of scripts to deploy multiple different containers, and then we learn about the Swarm, allow us to create a very simple cluster with a bunch of containers. Week 10 is the root project proposal and presentation, right? So this is the week 3. Assignment 3 release, and then you have to propose to me what is the CI/CD for LAMP stack, right? So for Linux, Apache, MySQL, or MariaDB, and the HP, right? So Apache, Linux. And then we learn about Kubernetes to the basics, and then in the lab, we actually learn about Minikube.
The next step we have to move from Java binary to
destination. But that is not like production level, right? So we want to learn something more real. Then we have to learn about EKS. So it's the Elastic Kubernetes Service. And then today is about revision and cost recap.
We have 2 commands.
Okay, so that's a lot of things we went through together.
We're doing that just to be sure that this.
So let's have a look at this, right? So this is the thing that we can actually talk about that.
And you
in the
will see
past,
that
in the week 1. So
it says
this is the
dependent.
I actually did some depth of job market research in Vietnam, right, and then make a list through nearly 100 jobs of DevOps, and I look through the job description and then based on the frequencies of the term appear in the job description, I make the cloud work here. So it means that the bigger the work, the more often that specific term appear in the job description. Right? Okay, so let's look into this in Vietnam. This is very specific in Vietnam, right? So let's circle the thing that we already know or we already learned, right? So definitely the biggest one could be
now it's time to
CI/CD, right? So obviously, right? So we already learned about CI/CD, no problem, right? Straightforward. Obviously, why it requires you to know about CI/CD. And then we learn about AWS here.
So please highlight line number 1 and
Okay,
line number
so
2 if you see on my
straightforward.
screen. So
The thing is,
URL and then
if you already know about AWS, most likely they will let you pass for the other cloud as well, because usually in the job description they will ask you that you need to know about cloud computing, right? Like AWS or GCP or Azure. So if you know one, you know all of them. Technically, you can argue to them that, hey, look, I know AWS and I know that other services are actually very similar, right? So you can pass the as well because you already know AWS. Definitely, you know SQL, right? Very important. Everyone needs to know SQL for the database. And then Git, you definitely learn about Git already. Definitely learn about Jenkins already. You learn about cloud for sure. You learn about Docker, right? Docker is really appear a lot in the job descriptions. And then Maven.
And after that,
Maven.
We finish with Jenkins. We have
to check
about
SSH.
Jenkins has correct.
About Bash script for sure.
That we expected.
So we know about server.
And we can go to
about S3. S3 actually very simple storage in AWS, right? So I assume that everyone must know about S3, but if you don't know about it, look into that. Super straightforward. Nginx, right? So we already deployed a bunch of Nginx container, right? And then deployment, we definitely know about deployment. We know about Java. We create a bunch of Java, Maven stuff already. And I assume that most people know about Python. The Python is teaching in the G1 of RMIT, I heard.
So you should be able to see.
And then EC2, right? Clearly, we know about EC2. EKS, we know about EKS. We know about Kubernetes, right? So KS is Kubernetes.
Now it's time to check the final.
Yeah, so Kubernetes here, really big one, really big. You can see that even though a lot of companies definitely they don't really need to use Kubernetes, but they do demand you to know about it, right? To be a DevOps engineer. And then Linux, definitely know about Linux a lot, right? We write some Linux command here and there.
You can also restart Jenkins service. You can also
DNS, domain name server, right?
Always please start with the first one.
We know about we play around with the IP address, we play around with the DNS, right? Because we use SSH to the EC2 through the DNS of the EC2 every time, right? And RDS is the database, right? So let's cross them as well. So if you know about database, SQL, you know about RDS. Technically, it's a scalable version of database.
Part of video about
RAP53,
Jenkins on AWS.
It technically allow you to connect the A record to domain name, allow you to expose that.
So in the first part
it's
of the
not
video,
like translate. Okay, it's actually a way, a service to translate the domain name, an actual domain name like www.mit.edu.vn to your A record, which is your public IP address.
The same algorithm, the same pattern, Python 3 and PIP3.
Let's see.
Okay, we got it. Command is called PIP hyphen version. Don't forget about
front end. Yeah, front end. You learn front end some already for some courses.
PIP version 20.
FTP, like FTP, like you FTP to that server, you copy file over. I think you already know about that.
We have to install a virtual environment or VIV. So we run in command sudo. So we have to execute this command with sudo permissions.
I would
install virtual in
virtual
env. On the
just Yeah,
Okay,
on the
that's
surface
it.
here,
Super simple
right?
installation. And
You
have to check the
mostly
version again.
cover everything already,
So
right?
the version
For
is
the
Visual
DevOps
ENV
landscape.
version 20.13,
So I
which
guess
is
the
it's a good
other
version.
time
Okay,
you can look into
in the next videos, if you
is
will run
definitely
PIP
Agile,
command,
right?
you
So
will see
Agile is the
yeah,
development life
the newest
cycle.
versions.
We will talk about that. We
21,
never
22,
talk
25,
about
and so on and so on.
what is actual Agile,
Okay,
how we
so
can practice
now
Agile.
it's time
right?
actually
So
to
at the end of the day,
try to run
Agile and
Jenkins.
Waterfall
We have to leave these
are
commands at this
part
time.
of software
We don't need to
engineer
install at this
development life
moment
cycle,
them.
right? We are
But we have
DevOps.
to try to
Definitely, we
run
don't really
Jenkins.
involve much
So how
in
can we
that
do
specific
that?
life cycle,
We are
but
going
because
back to our
at the end of the
EC2
day,
instance.
you are need to
We are
follow
clicking
the
on
life
this
cycle of the
ID.
development, right?
So
So
if you see this
development after they
message,
finish one
SSH
cycle, you
just
need to
click by
deploy
this
that
ID.
to show to the clients,
Okay.
and you need to be a
If you
part of that
do not
team.
see this ID,
So that's
just
why you
go
need
to
to
your
know about
instances
Agile
again
and Waterfall.
and just click by
And then
your
Elasticsearch,
running
look
instance. I
into
have
that. If you have
a lot of
time and
instances, but they're
Grafana
stopped.
for the
But I have only
monitoring
one
and
running
stuff,
instance. This is
right?
for Jenkins
Apart
server.
from that,
Just
that's
click
it.
by ID.
So technically, you are golden.
Okay,
Right? You are
please pay
golden.
attention to this.
Definitely
It's called
apply for
public
a
IPv4 address. We
junior
have to copy.
DevOps
Just click by
position
this
engineer.
icon. So this is my address. On your side will be
All
a
right.
different address.
So let's talk about
because
money,
it's
right?
dynamic
Because
IP
at the end of the
address.
day, we
Okay,
all
make a new tab.
care about salary and
Paste
money,
your
right? There's
IP
no
address.
point that you work if you don't have money.
And the port
So
we open
DevOps is one of the
8080.
trend that people really look into.
And
Right, so based on the survey
21,
here,
22,
this
25,
survey
and
is
so on
in
and
the
so on.
2019 from
Okay,
Top
so
Dev in
now
Vietnam.
it's time
You can
actually
see that
to
DevOps is in
try
the
to
top
run
position,
Jenkins. We have to
like
leave this commands at
18%
this
for
time.
the developers.
We don't need to
Top
install
two
at this
was
moment.
more
Then,
about
but we
machine
have to
learning
try to
and
run
data science, which is understandable why it's so hard, right? Because the AI, because of the stuff, the machine learning and the AI, they hype up in the article and the news, right? So that's why a lot of people care about that. But definitely DevOps is also very, very, catch a lot of attention from developers, right? So definitely we're on the right train. So on pay, right? So based on the more attentions, right? Because most of the developer they pay attention also based on the salary, right? You can see that DevOps specialists were also at the third highest salary compared to the machine learning and data science. So definitely for the full stack developer, you got less money. If you actually go for the mobile developer, you got even less money. Or game developer, you have even less money. UI UX, less money, right? So yeah, DevOps is actually one of the very good, job career prospect for us. And then based on your level, right? So also based on your level. So depends on your level 1, 2, and 3. You can see the level here. So if you are very beginner, you only know how to use some basic features only. So you got around $1,000 for your salary. But if you are professional use, right, you can get up to, 1,300. So 1,000 USD was around, I think 21 million Vietnam dong, right? So this one is around 32, 33 million Vietnam dong, and this one was like big high, like around 40-ish, right? Don't know how much, 40-ish. Definitely, it's a good money for you guys, right? Based on your level, and you actually accumulate that, right? So yearly you can earn up to 450 million VND. And this trend is continue to going up, right? So there is estimate that in 5 years, this trend is go up to around 668 million VND. So that will jump around 43% change. 43% increase for your yearly salary. All right, pretty good. I should say pretty good prospect here. So that's good. But right now, you say, hey Tom, I still have a few semesters before I graduate, before I can apply for a job, right? Or you say, Tom, I'm not really confident about my DevOps when I apply for a job. So is there anything that I can, make myself more confident, make myself, more valuable in front of the employer, right? So one of the best way is to actually go for the DevOps Cloud certificates. Okay, so I'm gonna give you a few suggestions, and then for each of them, you should really look into it, right? If you want to get the class certificate, you need to pass the exam, right? So the first one I would recommend you guys look into it is the AWS certified DevOps engineer professional, right? So this one is allow you, okay, this one is testing you to make sure that you have the ability to automate the testing and the deployments on the AWS infrastructure and applications. And the nice thing about this is you can actually look into this. You can schedule exam. You can download the exam guide or download the sample questions, right? So this is one way for you to prepare for your exam. Another certificate is on the Azure, right? So if you're like, hey, I don't like AWS, I want Azure, then you can look into the Azure DevOps Engineer certificate, right? So there's 3 levels: the fundamental, the associate, and the expert, right? So you can see the roadmap here. So you go for the fundamental, right? And then you finish that, you go for the associate based on administrator, the developers, and then you go for the expert one, the final level. Right, so you can definitely look into that. There's a links here. You look into that. For each of the level, what do you need, right? What is the example and stuff. All right, so last one will be the GCP. So far, for anyone that really want to do the Google Cloud Platform class certificate, you can go for the GCP Professional Cloud DevOps Engineer. So this specific certification gonna test you to show that you can apply the site reliability engineers principle to the service or not. You can optimize the service performance. You can implement service monitoring strategy. You can implement CI/CD pipeline for the service, and you can manage the service incidents. Right? It's like something happened. Can you manage those incidents? So definitely you can look into the links again. All the information available for you to look at. Right, you can download the exam guide. You can go through all the sample questions and stuff. So I think that is one of the very interesting for one of the solid career, building that you need to do after you finish the course. Right? You want to like learn more. You want to do more. You want to get certificate. Right, you can do that. Okay, but if you don't really care about these 3 certificates, you're like, hey, I really just want to do the Kubernetes only, right? Then we have option for you, right? So you can go for the Kubernetes Cloud Native Associates, the KCNA, right? So this specific certificate only testing your foundation of knowledge and skill in Kubernetes. So you can look into this. So this is not hosted by AWS or Azure or GCP. Is hosted by the Linux Foundation, which is like very big organizations when it comes to cloud computing, right? So you can look into this, or you can go for the certificates Kubernetes application developer. So this one is more focused on applications. So this specific certificate gonna test you if you can design, build, configure, and expose the cloud native application for Kubernetes or not. Right, so this is what is more practical, I would say, when it comes to deploy application on Kubernetes. We can see that there's a lot of things we look at that. Okay, Tom, do I do this, or that, right? So that's why I'm gonna provide you the roadmap. Depends on what you want, right? So if you want to build a career as a system infrastructure, like for example, this title could be Big Data Engineer, the Cloud Architect, the Data Analyst, the Database Admin, the Site Reliability Engineer, the System Administrator, or the DevOps Engineer, right? Very specific when it comes to like system, sysadmin, and infrastructure, right? Then this certificate gonna be useful for you, right? For example, let's talk about only for the AWS. Then you should go for the AWS Solution Architect. Okay. All right, so if you want to be a career as a network security, for example, cyber security analyst, the DevOps operation admin, the information analyst, the network administrator, and security engineer and tester, then you should look into, for example, if you talk about only AWS, you should do the DevOps engineer. But if you are just a web developer, let's say you are web development only, you could be backend developer, data scientist, front-end developer, full-stack developer, mobile app developer, project manager, or web development, right? They're purely software engineer, right? And you want to do some cloud computing to show that you can develop application on the cloud, then you should take the AWS associate developers here. Okay. Meanwhile, you definitely for each of the organization here, they also provide you alternative certificate for you to take it, right? But I'm to save time, I only talk about AWS only. Okay, so you can see that there's a lot of options for you to play around and to choosing what is a certificate actually suit your need. Okay. All right, all good. Any questions? Okay, so this is a very special section here. The thing is, I saw a lot of students after they finish the course, they're like, also, I want to apply for a job. And then they really struggle to figure out what they should put in the resume to make it look cool and also to show the employers about, your skill and your level, right? So to help you out with your future career, I also gonna have a very small section to suggest and maybe to guide you about, what you should put in your resume, right? When you apply for like DevOps positions. For the summary example, right? So it could be about these are the sentences. I think it's actually quite interesting and also quite powerful for you to refer to it, maybe paraphrase that. For example, skilled IT professional with some year experience in DevOps and scalability engineering experience in design, automating, and optimize mission critical deployment in AWS, leverage configuration management, CI/CD, Docker, Kubernetes, and DevOps processes, right? You can say that this is a very nice sentence because it contains all the big word and all the tools that you are actually have been learning in the class. Or for example, another one would be around year of experience in IT area, comprising of configuration management, deploy, CI/CD pipeline, AWS, and DevOps methodologies, right? And then next one could be proficiency in developing the continuous iteration, continuous deployment, delivery pipeline. Okay, so these are a nice summary for you to refer to, paraphrase that. Please don't copy 100% there because, it's paraphrase, it's a plagiarism, right? So just refer to this as a summary in your resume. And for your experience sections, here are some of the examples. The first one would be the experience in the AWS cloud computing, right? And features like EC2, S3, RDS, CloudWatch, IAM, VCP, and autoscaling, for example. Or you could put in container orchestration using Kubernetes, install and design Kubernetes cluster, running job, and deploy pods, right? Which you did in your week 12. And then, or you can put another sentence like developing script for building, deployment, maintain relational tasks like Jenkins and Docker, all right? Or you can put implement CI/CD pipeline for application deployment using tools like Git, Jenkins, Docker, and Kubernetes. Or you can put in a sentence that configure Jenkins job with Maven build tool and accomplish continuous deployment by integrating Ansible and Jenkins using Jenkins plugins. All right. Or also you can use experience in usage of data center automation configuration management tool like Ansible and Docker. Or you can say written an Ansible YAML script to configure a remote server. Or you can say that managing and maintaining the Kubernetes infrastructure and architects, right? Or you can say schedule builds overnight to support development needs using Jenkins, Git, and Maven. All right. Or you can say that experience in using Apache Tomcat as server application for deployment. You can say that so many different ways for you to actually mention those experience in your resume, right? So yeah, so look into the syllabus of the course again, and each of the week you can write one sentence about your experience, right? And then if you want to, you can have a sections to actually talk about your technical skill, right? For example, for your version control tool, you're using GitHub. For your build tool, you're using Maven. For your CI/CD tool, you're using Jenkins. For configuration management, you're using Ansible. For web server, you are using Apache Tomcat. For scripting language, you are using the Bash script or Bash shell script. For the containerization technology, you are using Docker. For deployment and orchestration, you are using Kubernetes and Docker Swarm. For the Docker registry, you can using Docker Hub. So for people who already learned about the Elastic Container Registry, right? So ECR, you can put here as well. For the cloud environment, you can put AWS. And for monitoring tool, you can using the CloudWatch. Okay.
So how can
so these are very nice summary
back to our
about the technical skill when it comes to resume.
ID.
All right,
so you see this
I hope you, after finish the course, you start to like revise and polish your resume. Okay?
If you do not see this ID, just go
to
again, and just click by your running instance. I have all other instances, but they're stopped.
Let's have a
but I have only one running instance.
And
this is for Jenkins.
I will quickly go through the weekly summary.
Okay,
I'm gonna
please pay attention to this section. It's called public IP
to revise everyone that what we have learned so far.
So this is my address. On your side will be your different address because it's dynamic IP address.
So let's have a
make a new tab. Paste your IP address.
To you.
And the port we opened 8080.
40 AM.
Enter.
And then we're gonna get back to this.
Okay, so the good news, Jenkins is running, but Jenkins is asking you to unlock this password, because right now we have to just go to this location using our terminal, using Ubuntu server. We have to go to this file, and this is not directory, so this is a file. It's called initial admin password. So we have to use cat command, CAT, and this address just to get initial Jenkins password. So it's going to be a big big amount of numbers and symbols. Let me show you. So just copy this address, open your terminal. Let's start with sudo cat, and then just paste your address and press enter. On my side, this is my number. On your side will be probably a different number. Just copy. Go here, administrator password, paste it. It's not visible, do you see? And select continue on the bottom right. And we don't need to check. We don't need to just check passwords and save passwords. Okay, customize Jenkins. So we have two options. Plugins extend Jenkins with additional features to support many different needs. So if you want to simplify the process, I recommend you install suggested plugins, and Jenkins will install plugins for you. It will be big amount of numbers, big amount of plugins and options. But I think I can show you another option. This option is called select plugins to install, because for our Jenkins Selenium Python installation, we don't need to install everything that Jenkins wants to install. But I have to install. Okay, just click. This is called credentials bindings. This plugin integrates Git with Jenkins. Okay, just select this Git. Okay, do not press by install yet. Remove Git from this list, and credentials binding. So we have to use these credentials, like it says allow credentials to be bound to environment variables to use from miscellaneous build steps. So how it works, when we will store our Jenkins credentials, we have to store them somewhere in Jenkins. So I mean Git credentials. So for these purposes, we can use credentials binding, and this option will give us to store Git username, Git security code, and all information related to Git integration with Jenkins. So select credentials binding. We actually selected two modules. It's called credentials binding and Git, nothing else. We don't need to install Selenium, we don't need to install Chrome driver, nothing else. Okay, just click install. Okay, other than that, after Git and credentials binding, Jenkins is installing all these additional modules and libraries. Yeah, we just need to wait for them. This section is about create a first admin user. So we have to provide information, what's going to be a username, password, confirm password, full name, and email address. I recommend to use something super simple that we can never forget. So let's say admin and password. Again, if you wish, you can change them later. But just for the first one, for the first admin user, maybe something super simple, just for training purposes. Okay, confirm password is going to be password. Full name, Mike Pavlov, will be enough. Passphrase. Again, no enterings, not just to be sure, and paste. And we have to make this selection. So select the checkbox, allow write access. So yeah, because if you want to update our repository or get information, so it's better to allow write access. Add key. Confirm access. Yeah, this is okay. I can confirm my access. I can enter my password, or I can select if password and username were saved.
Okay.
I can select my username and then confirm password, because this information is really important and secure. All right, so what it says, deploy keys. I have Jenkins -GitHub. This is the description of this scope. So unfortunately, you will not be able to copy or like open or edit your SSH key, right? To select second option on top, it's called SSH username with private key. Just click on it. Okay, just wait a little bit, and then we have this scope. We're not changing here. Scope should be the same. ID. It's up to you, but I'm usually doing this ID, like GitHub SSH key or something that you can explain your ID between Jenkins and between GitHub, for example. So GitHub -SSH-key will be okay. Description, I don't know, description code.ca or description, up to you. So it might be your GitHub username and RSA, but without pub at the end, extension, pub extension. So greetings again, this time to finalize, specify our Git. Just have a execute Windows batch command, execute shell, and invoke top level Maven targets. We just need to select execute shell, second option on top. You can expand this field at the beginning. It's only at the beginning. After you apply and save, it will be super tiny and small. All right, commands, guys, you will see in my script, but let's start with the beginning. So this is general Moodle Jenkins script, execution on the Jenkins side. So just copy, this is the command. So set up a proper path, and then we will call a virtual environment. We already installed this library, and this directory is called VNV. Okay, so we will execute virtual environment. We'll create a new virtual environment with the name VEN. Is we are user log V is not installed or activated or present. So VNV, then bin and activate. The next step, we have to install a few libraries. Activate. So second one is called Faker, but one more will tell you about that. Yeah, we have to be but Jenkins factory, where we have our Moodle _ tests file, py additional folder name. Please go to this directory. It takes resource, right? Doesn't make any sense. So you run your code, activate it environment, execute everything, install everything, and deactivate. Okay? This is pretty much done. Just hit apply, and we have to save our project. Let's check one more time. So project called Python Selenium Moodle. This job is to run Python Selenium Moodle with Moodle application on Jenkins on using AWS instance, and cloning the remote Git repository. So do you see? Because Git and Jenkins have this integration, secure integration using SSH connection. So Jenkins is able to get, like, clone our repository to the local environment. Okay, so this is cool. All right, to check in our revision, commit message removed from driver. That was my message. It's not related to actually our job. Yeah. What else? Okay, we create a virtual environment. right? Because we have this command. We activated virtual environment. Virtual environment, so many things. And okay, so we executed first one, pip install faker, collecting faker. Do you see installation? Because here we created a brand new virtual environment here. It's not the virtual environment from our local machine. So every time when we'll run this build, Jenkins will create a new virtual environment, a new one. And that's why we have to collect Faker, we have to install Faker, Selenium, and Python every time, because every time the virtual environment will be brand new. All right, so collecting Faker, all these dependencies from Faker. Next command is called pip install Selenium. All these Selenium dependencies, Trio, Selenium, IDEA, certify, so many things. Installing collected packages, successfully install. And finally, pip install PyTest, collecting PyTest. Okay, so requirement already satisfied. Okay, it's fine. What's next? Config installing packages. Okay, successfully install everything. Now the last command in our code, in our script, it says Python unit test discovered pattern Moodle_tests. This test ran in the one test ran in 53 seconds. But guys, why it took longer than 53 seconds? Because before we start actually this command, we executed other commands. We executed command like create a virtual environment, then install Faker, install Selenium, install PyTest, and only after that Jenkins executed this Moodle_test py command, and it took 53 seconds. So in total, I think it's more than 53 seconds. It's like 1 minute and 15, maybe 20 seconds. Okay. Yeah, this is something really cool. This is our test, right? In headless mode, but we're still seeing all the messages. Like we landed at the Moodle page, we're seeing these messages, dashboard is present, so everything we expected, right, from our script. And after that, deactivate. So we deactivated our environment, and do you see it says old virtual path? So many like technical information that you don't need to care about. But this is our expectation that we finished our test. And so pretty much this is pretty much done for this project, for this Python, Selenium, Moodle, Jenkins, AWS integration. Hopefully you like this information. And again, this list of commands will be added to the description of this video. I just want to pay your attention, please, to this section. So first of all, install. Secondly, initial installation. Secondly, install Google Chrome, one by one, command by command. After that, just summarize, install Chrome driver. Please pay attention. Google Chrome web browser and Google Chrome driver are different things, different binaries. But we have to be sure that Google Chrome Google Chrome browser version should be identical that Google driver binary. Okay, so please don't forget to specify number here. So Google Chrome and Chrome driver should have the same number. Not necessarily this one, but identical number. To install Jenkins, we have to install Java Jenkins installation, check status, but to see it's optional. Just try to run this command. Python installation, virtual environment. We don't need even this one. Just create a virtual environment. I think it's not necessary. What I want to show you one more thing. So we didn't do this part in our video. So this is called open the firewall for Jenkins connection. Because do you see, when I created my instance, when I launched my EC2 Ubuntu virtual machine.
Chạy đó, rất là nhớ. cái setup mình viết lại nha. Yeah. Stupid, man. Stupid. Huh?
All right, testing. Can you hear me? Guys, let's get back to it. Can you hear me? All right, good. So let's get started. Okay, so weekly summary. There's something wrong with my webcam though. I can't turn it on again. Let me try. Okay, it's working now. Fine. Okay, let's try that. Weekly summary. So week one is a cost overview, the intro to the ops, the tool, and the environment setup. Right. We talk about what is CI, so continuous integration. We talk about CD, the continuous delivery, and the DevOps. So we actually show you guys what is the basic pipeline of the CI/CD, right? So these are the CI and these are the CD. Technically, this one is the pipeline for the build for the build project, and this one is the pipeline to release the project. And then we make the distinction between the continuous delivery and continuous deployment, right? So continuous delivery is when you can release it anytime, right? Technically, it's actually smooth. Technically, someone needs to approve the deployment for that to happen. Continuous deployment is done by automatically, right? So it means that after you test it, if it passes all the tests and the whole project is automatically deployed to the productions. And we actually show you how the difference between that CI, the continuous iteration, continuous delivery, and the continuous deployment, right? At each stage. So continuous iteration was from the source control to the build. Continuous delivery is from the source control all the way for the approved deployment. And continuous deployment is from beginning to the end. All right, so that's it for week two. We talk about the intro to Linux and Linux command line. So we went through a lot of stuff together. So technically, you can say that we using the host operating system like Mac OS in the lab, or in your case, it could be Windows. And then we can have a Linux virtualization on the top. So in our case, we are using the EC2, right? And then we install a bunch of DevOps job to do our lab. Right, week one, week two, we actually set a very simple virtual box to apply to do the lab for the Git and the Linux command line. And these are the command line that we did in the lab, right? For the date, UMI, echo, pwd, ls, Mac directory, cd, touch, cat, head, tail, wc, mv, cp, rm, wrap, history, sudo, nano, bash, right? And then in your lab, right, we went through 6 different challenges to practice your command line interface. All right, for week 3, we actually learned about Git and cloud computing AWS. We talk about Git, GitHub, and AWS, right? And then we learn about Git flow. So Git flow is a normal flow of Git, including the add, commit, push, and pull. And then I show you how to set up the EC2, very simple way to set up EC2, right? For the AIM, for the instant type, for the configuration instant, then you have storage, right? And tag, and then security root, and that's it. And then for week 4, we talk about the Java, Maven, and Tomcat. So we learn about these 3 things. So we're gonna choose these 3 as our, development stack for the course. And then we'll actually build this very simple diagram in the lab, right? So we're using Maven to generate the base web Maven project. And then using that, we're gonna using Maven, we could create the artifact WAR file, and then we copy that to the Apache Tomcat, and you can see the website on the through the public IP address. And then you learn enough to do your assignment 1. So Java, Bash script, Git, EC2, AWS, Maven, HTML, CSS, Tomcat. Yeah, this is your assignment 1. Week 5, we learn about Jenkins. So we want to build a very simple CI/CD pipeline, right? And then Jenkins, actually Jenkins can do a lot of stuff with plugins, right? For build, for version control, for continuous monitoring, for the continuous testing, for the configuration management, for the continuous deployment. And yes, so Jenkins perfect job when developer they commit the code to GitHub. Jenkins pull the code to build the code, and then if the build fail, it can notify the team. And this is a very basic CI/CD pipeline. We already talked about that. And yeah, so technically, the most important thing about Jenkins is you can install a lot of plugins to make Jenkins super powerful, very, very powerful. That fit most of your DevOps, fit most of your DevOps demands and also needs, right? So when you build a pipeline, you have some specific need like Selenium testing and stuff, right? You search for it, there should be a plugin for that. All right, so and then for that lab number 5, we actually integrate Jenkins to our development so far, right? So it's not like build normal development flow. We actually including Jenkins allow us to automatically pull the code from GitHub, build the project, copy the artifact to the Apache Tomcat, and display that on the website. Yeah, so definitely for this specific lab, we are focused on Jenkins, right? Jenkins for the pipeline. With number 6 about Docker container. We talk about, we actually learned the difference between bare metal, virtual machine, and container. We actually learned that the container are better, right? Because they actually use less resources, take less space, and move faster compared to the virtual machine. And then we actually talk about the problem of the metrics from hell, that without container, what's going to happen, right? Because we have a bunch of different applications, and each of them have a different requirements for dependencies, right? So that would be really challenging to set them up. But with container, we actually technically group them into different container, and we can host them on the same server or machine with no problem, right? And then that is technically the container was like the most important thing that if the developer, they're gonna give the DevOps team, right? It's like, here is the Docker image, deploy that, right? In the past with our Docker, they have to give you the WAR file, right? With the guide that, hey, how to set them up. And then we went through different terms for Docker regarding Docker engine or Docker daemons, Docker file, Docker image, Docker container, Docker history, and Docker Hub. And then, yeah, we have been playing around with Docker Hub a lot, specifically for your lab and for your assignment 2 as well, right? Because you are required to, building your custom image for Jenkins and Tomcat. Not only that, you also have a bonus mark if you push those images to the Docker Hub and pull it from there to deploy it. Okay. The flow, the container pod mapping, right? And yeah. Okay. Week 7 is the personal development week. Actually, we went to the community trip and the guest speaker at VNG. Right? We have these together, have a lot of fun. And in week 8, we actually have the Ansible as a topic. We learn about Ansible, we learn about feature installations, YAML file, playbook, inventory, module, right? And then we compare between Ansible and Dockers. So yeah, Ansible playbook is really simple, fast, powerful with the module, right? So if you write Bash script, it's going to take a long time. But if you write Ansible with the specific module, it's actually really simple. And the nice thing about Ansible is it's agentless. It means that you don't need to set up Ansible on these different machines, right? Technically, you can control them through IP address and SSH. And then, yeah, so for Ansible, you can write YAML file for the playbook. Technically, it's like a script where you can determine what is the host where you're gonna apply the playbook to, and then the task that you want to run for the specific script. But what is the task that you want Ansible to play? Okay? It could be install the HTTP. It could be make sure the HTTP is up. It could be create a container. It could be anything, like based on the module. And you can see that these are examples of using Ansible module. You can like apply these for the PostgreSQL. You can using to create Jenkins job as well. You can using Docker module to create a container or to actually make sure the container up or down. And then the difference between container, Ansible and Docker is for Docker, when you write Docker file, right? This file only applies for Docker container. But the nice thing about Ansible playbook is you can write a playbook so that it can apply for all the environment as you want to, because that is the powerful. It's a power of the playbook, because it's actually general. It's not specifically for any specific technology. And the nice thing about Ansible is it's not container, right? Because if you write a container, you can only control what's inside the container. But because using the playbook, you can create container, but also you can control whatever inside your server, right? So that is the nice thing about Ansible. And yeah, so technically we actually build the lab, Cat complex, and we are using Ansible for that, right? So this is the previous lab, right? So with the Docker image and with the this and that, so we need to using Jenkins to copy the word artifact, right? And then at the same time using Dockerfile to build the image from the artifact, and then you know using use another Dockerfile to create a container, right? And then host the server. But you can see that without Ansible, there is a lot of ugly stuff here. So technically, you write some code to actually build your Tomcat, and some code to run the Tomcat container. But with Ansible playbook, everything was like really clean up. So technically, this is the playbook to build and push to get to the Docker Hub, and this is the playbook to pull from Docker Hub and create container. So you can see the cleanup. And the nice thing about this is this script can apply for many different servers, right? Imagine you have like 5 or 10 servers. With this script, as long as you change the host group, you can apply the same script for 10 or 20 different servers. But this one, not very straightforward. Okay, and then for that lab, you're gonna using Ansible, right? So technically, you copy that word artifact to this server using the Ansible playbook with the Docker file to create Docker image and push the image to the Docker Hub. And then later on, Jenkins is gonna call in another playbook to using that image from the Docker Hub. You pull it and you create a container here and you serve the website. Basically, in this lab, you are using two different playbooks. All right, week 9, Docker Compose and Docker Swarm. All right, so technically it's not run line by line, right? Line by line, Docker run image, Docker run image, Docker run image. You can just write one single file with the Docker Compose like this and say Docker Compose up. It's gonna create these 4 containers for you like that easily. And then we went through this specific applications example to actually launching the voting app example using Docker Compose. And then we talk about the container orchestrations, right? So this is orchestration. Let's say you have a bunch of server. How can you control them, right? And also, what if one container is down, right? How can you relaunch it? And also, how can you scale down the application, the number of applications based on the demand of your request from a user, right? So the whole thing about deployments, managing container is actually the container orchestration. And we talk about these 3 technologies of container orchestration, which is Docker Swarm, Kubernetes, and Mesos, right? And for Docker Swarm, you have the Swarm here. You got a bunch of different containers, and each of them are Docker hosts. And we actually practiced Docker Compose with Docker Swarm with these specific applications. Yep. So for Docker Swarm, you create 3 different containers for Nginx, right? And then using that, you create a cluster with 3 different containers, and then create a load balancer to share them, right, to expose the container to the world. All right, week 10 is proposal and then consultations. So we have our assignment 3, right, which is hackathons, and I'm building this website, RMIT store website, e-commerce website using LambStack, right? So Linux, Apache, MySQL, or MariaDB with PHP, right? Definitely, you need to build CI/CD pipeline. You need to propose that pipeline to me. For assignment 3, and then week 11, Kubernetes, right? So we went through that. We compared between Kubernetes and Docker Swarm, right? So definitely, we don't need to use Kubernetes every time, right? So Kubernetes is going to be very, very beneficial when it comes to very large application with some specific use case, right? So yes, not always, but it's actually a very trendy technology. As you can see that, because a lot of job description have Kubernetes in the job description for DevOps. So that's why it's good for you to know about and also have some experience launching the container. And then we actually mentioned that how Kubernetes, we talk about this specific case study of Kubernetes actually combined with Pokemon Go to actually improve the scalability of this specific game applications. And then we actually talk about the master node and worker node in Kubernetes of different components here, the Q API server, the etcd, the controller, the schedule, and for the worker node, we have the kubelet, the container runtime. Yep, so we went through a bunch of Q-control command, right? And these commands you're gonna practice more in the lab already, right? So we talk about Kubernetes manifest. Technically, it's a YAML file allow you to launching different pod quickly. Technically, either service, pod, or deployment in the Kubernetes. And then for this week 11, the lab, we actually introduce you to the Minikube, which is like a very lightweight version of Kubernetes with one single node only. Yeah, one single node only. Right, so very simple application to play around with, right? And then every single pod you deploy, gonna deploy on the same node. Yeah, so keep it simple. And then for the lab, we went through the playground prepared by Google, right? And then also went through the tutorial of Kubernetes from Docker. And then I also show you guys a tutorial how to set up this specific voting app using Kubernetes. All right, so week 12, super straightforward. So far in 11, we only focus on Minikube. In week 12, we also move on to learning the Kubernetes on AWS. Specifically, we're learning Elastic Kubernetes Service, EKS. And then, talk about this already. All this I already mentioned about today. All right, so good. That is the end of week 12, right? So what is my final thought and message for you guys? Okay, I know that this course is challenging because you have to learn a lot of things every week. It's always challenging, right, to learn stuff. But trust me, the secret of success is to get 1% better every day. So what does it mean by that? It means that when you think about it, right, every day, you just need to work on something, like slightly improve every day. Try to learn something new every day. You don't know about Kubernetes? Learn one aspect of Kubernetes every day. And trust me, after like 20 days, you become much, much better. So let's prove that, right? So this is the power of tiny gain. So 1.01 is technically 1%, right? And power 365 means that if you try to be 1% better every day in a year, you'll be around 37.8 times better than what you are on the first day of the year. All right, imagine. So imagine something like gym, right? It's like, hey, I want to lift heavier. I want to run further away, right? For example, you have a goal, and then every day you do the activities, and you just try to be just 1% better every day, right? So by the end of the year, guarantee you'll be 37 times better compared to what you are at the first day of the year, right? Always. But there's something apply with you, right? Let's say you are slacking off. You don't work hard. You don't study hard. You don't try to be better every day. So you get worse every day, right? So that's 1% worse every day. So if you are 1% worse every day, after a year, you would, so from 100%, you become 3%. This means that you become 97% worse, right, by the end of the year. Right? Think about everything, all the aspects in your life, right? So if you don't work for it, you become worse. But how worse? Exactly 97% worse, right? And if you actually try to be better, just 1% every day, you will be exactly 7 times better. So given percentage, right, that will be around this. Yep, so 3,700% better by the end of the year. That's a lot of numbers, and you can see that this is actually relevant, right? Because by the end of the, you can see that when you improve 20% better every day, it's increasing faster and faster because it's actually exponential, right? And the same thing with when you try to get worse, right? So that's why at the end of the day, if you are struggling in the class, doesn't matter. You just try to work on that every day. And I guarantee you that your GPA will improve, your score will improve, your script, your technology, your skill will improve, right? Just stick to that every day. In fact, so if at the beginning, there's a valley of disappointment, it means that you work really hard, but nothing coming out, your GPA doesn't improve, you can't do assignment, you can't do the project, right? But trust me, after you work hard, eventually reaching a point that things actually happening, right? So this is what you think happening right now. You think that it's actually linear, right? You think that's linear. Right? It's like, hey, I try to learn every day, actually improving. No, you're gonna commit some initial time first, and eventually it's rolling up. It's going up. So your performance is actually outperform your expectations, right? At the beginning, you always underperform compared to your expectations. Okay, so that is the idea here. The idea here is, I know that people are not genius. I'm not genius, right? We have to work hard every day. The same thing with every single course. If you think that it's actually challenging, right, for DevOps, you are correct, because this is the whole roadmap of like 6 months to 1 year of effort to actually be good at DevOps, right? So this course is actually an initial effort to push you into the right directions. But it's up to you to, if you want to take the journey all the way to the end, to complete the journey, right, with the right mindset. All right, so that's it. That's it for my talk and encouragement. Thank you for your listening. Once again, I'm actually very honored and very proud of you guys for sticking with me for 12 weeks. And I can tell you that this is a very challenging course. There's a lot of things we learn, a lot of things we do, but it's a part of something great if you want to go for DevOps in the future. Even though if you don't go for DevOps in the future, you become let's say a software engineer. DevOps knowledge also gonna help you to get promotion, because you are DevOps gonna set you apart from a normal software developer, right? Because you can do the pipeline, you can do cloud, and when you work for the startup, right, you technically do everything. Right? The more value you can bring to business, the more valuable you are, and the more higher salary you're gonna get. All right, so that is the idea. All right, so is there any question before we gonna sign off early for today? Minh, Man, and Vic, I can see that you guys always in the lecture regardless the time, and I'm actually really proud of you three. All right, so is there any questions before we say goodbye? Any questions? Anything? Any comment? All right. So if there's no questions or comment, let's sign off early for the lectures. All right. All good. Thank you, Man. It was an honor to teaching you guys, and also I'm actually really enjoy teaching and also helping you guys throughout the journey. So thank you. So hopefully I'm gonna see you again in the lab. All right, and then with DevSecOps, do they just automatically security testing? What do you mean by that? Yeah, so I would say that from the term, definitely you need to add the security component into it to make sure that you do more security testing. Correct. Security testing, and also not only the testing, but also you need to make that happen, right? You need to add some security layers, security root and stuff, right? So the isolation of the network and stuff. Yep. All right. So, all good. Is there any other questions? So once again, so this course only barely reaching the surface of DevOps, right? But definitely it's enough for you to apply for internship or the junior position of DevOps. Okay, for sure. All right, all good, guys. I see you guys in the lab then. Okay. And remember, we have the pizza party on Friday, so make sure that you sign up for it, because the link is in the announcement, right? So. Yep. So we have two announcements here. You forgot to say that. So for the assignment, right? So if you need any help, right? Because I'm marking my assignment. Sometimes I'm really busy. I couldn't answer the email quick enough. So definitely I can set up this time for you guys to drop by. Like you can drop by anytime in the SCT office in this time, so that I will help you out. Like we don't need to book for it. You just go for the office and ask for Tom, and I will talk to you about it. Okay, so this is the actual help for your assignment 3. And also we have a pizza party on Friday. It's actually at 4:30 p.m. on Friday. The location is really straightforward. We're gonna meet each other at the Boost Juice Shop, right? So to make sure that you for the slot, you need to sign up for the form. Okay, so the deadline for the registration is actually at midnight today. So make sure that you sign up for that. Okay. All right. So maybe I see you guys on the workshop, no, the lab for this week. Also maybe for the pizza party for this week as well. Okay. All right. So if nothing else, then good luck, guys. Good luck for your career. Good luck for your assignment 3. I see you guys later. Thank you, Vic. Thank you.
Okay. Star section run. Rồi mất rồi đó mình sẽ cái chat này. hả? Cô mà đơn cô mà đơn ba bất là kề Marcus name cô mà đơn ba gì class name viết tắt vậy không truyền được. Tìm mẫu rồi tắt content ra. Một chút cây mèo này zoom á. lắp chân. Chú bị lỗi gì? Supaya again, and hopefully this work will pass because the websites are muốn chạy test rồi đâu chết mẹ. Sửa cái công suất lại thôi nè, sửa cái công suất này lại thì mới thấy không. block rồi.
that.
Okay, let's work. Let's go. build to install apply dependencies. No, we really need the microphone. No, put it there. Dạ. 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 Fuck, that's a big one.
Bob.
Okay. Oh shit! I forgot to study the shit. You're gonna kill me. I forgot to study for the web programming. Shit. What? Okay guys, that's the end. Remember to like, share, subscribe.